Hello world, Microcats! We continue to work with the input-output expander. This time we use the encoder together with the input-output expander. Port A has 8 LEDs and port B has a 7-segment LED, and we additionally connect a dual LED. Turn on the power and look at the indicator for the encoder count, as well as the bit number for the red leads. Now bit number 0 is 1. The values on the 7-segment display are also 0. A green LED indicates that the direction is clockwise. We begin to turn the encoder knob clockwise. It counts from 0 to 7 inclusive, while the red LED turns on in turn. The 7-segment indicator also changes its value sequentially. After bit 7, bit 0 begins, that is, the account is looped. After turning counterclockwise, the red LED turned on and the green one went out. And so, clockwise green is on, against red. When the encoder moves counterclockwise, the 7-segment display decreases. The running LED moves in the opposite direction. Let's move on to the electrical diagram. The control device is an encoder. Its CLK and DTA lines must be connected to channels 1 and 2 of a STM32 microcontroller timer. The microcontroller via the SPI interface is connected to the MCP23S17 register. The register uses both ports. Port A has 8 leads, port B has a 7-segment LED. A double LED is used to indicate the direction of rotation. Let's move on to the software part. In the main function we initialize the peripherals. We configure the MCP object, connect the pins with signals, register the hardware address and SPI interface. We set up the encoder object, connect the pins with the signals, set the maximum value of the encoder count and the timer used. In an endless loop, we get the value of the encoder counter, the direction of rotation, as well as the state of the button. We send this data to the input-output expander. For port B, we call the function of displaying the number on the 7-segment indicator. For port A, we light the LED for the corresponding bit. Depending on the direction, either the green or the red LED is on. The number mapping feature works by using an array to convert the numeric form to bytes to control individual segments. The array is created according to the indicator connection diagram. The pins to the encoder signals are configured as input floating and the encoder button as input pull-up. The timer used in the object must have a prescaler value of 0. The reset register value is the maximum value of the encoder counter. We capture impulses on the leading edge. The rest of the functions are wrappers for the standard library. Using them, you can find out the value of the counter, as well as the direction of rotation and the state of the button. That's all, see you in the next video. Subscribe, Microcat.